a little deeper look into our cloth effects. I'm going to load up the scene that is available on the CD. As we scrub through this, we see we have the forward and back motion. Nothing is happening yet. We will apply our cloth effects, calculate, and we have that nasty floating off into the distance kind of thing, because there's nothing fixed on here yet, and there's no action other than the keyframed motion that we put in there. So our curtains are just kind of floating off into nothing. The first thing we want to do is, let's just fix by point set, which I happen to know, and you can see it here, the set of points. Now if we recalculate that, I'm going to open up my FX browser, which is this handy thing right here, and hit the start button, and there we go. It goes flying off, exactly how you'd expect it to happen if you were, say, in a spaceship in zero gravity. There's a couple of things we can do to make this better. We can go into our settings. We have a lot of settings here. Some of them make a certain amount of sense and are straightforward, others not so much. One of the quickest things you can do is just jump right in under the Etc. tab. We have presets. The default preset is cotton, but we also have a number of other presets. There's cotton, cotton thick, silk, rubber, and jelly. Let's go to rubber, recalculate. We have a little bit different motion. It looks to be a bit thicker. And actually, if you go in, you'll see that a number of your settings change when you load up the presets. Now, part of the problem we have here is that it's still in zero gravity. So let's just go right in and take care of that. And we'll recalculate this. And scrubbing through, actually have a fairly nice cloth simulation here. Even though what I chose to use was rubber, you would think intellectually that you'd want to use like silk or cotton as a preset to get nice cloth. Not necessarily. As you can see, this does a nice job with the curtains. But let's go in and try one of the other ones. So again, in etc., we'll try silk and see that our gravity still stays the same. So we will calculate this once more. And scrubbing through. For some reason it seems thinner now. This type of motion, this type of simulation, it is so subjective. When you look at something, the way it moves, the slight bit of tension, the slight bit of stretching, all gives you visual, kind of emotional kind of clues, things that make sense when you watch. And that's why I set my gravity to -2, when it, in actuality, to be physically correct, this should really be a -9.8, I believe. You calculate that. And as in most of show business, it's not so much about what is accurate or correct. It's what looks cool and what works for the particular project. Now this isn't too bad. The silk preset does not have a lot of stretch to it. There are two ways to improve the quality of the calculation. In this case, we have resolution under our Etc. tab. The resolution means when it's calculating the dynamics, it basically breaks your geometry up into grids to calculate. And it defaults to, in this case, a 10 millimeter square. So it basically chops it up into a 10 millimeter square and calculates how one block, it's as if you have a quilt just made out of 10 millimeter cubes that are all strung together, and it's calculating just for that block. I've taken this down to 1 millimeter and recalculated it, and I have a much more smooth action, much more pleasant, realistic kind of motion to my cloth. Now, I did that while I was temporarily offline, so you wouldn't have to sit through and watch it calculate, because it did take a number of minutes. The thing is, the basic motion, the very basic motion, is still the same, even though the resolution is set different, which means you can set up your actions with a much larger number to do the gross calculations. Get yourself in the ballpark. Once you get really close to what you know you want, then you can set your resolution down to much lower. Also, is working with your subpatch level. If you have a subpatch object, that is. And in most times when you're working with cloth, you don't want to be locked into one level of geometry. You almost always will want to be working with subdivision surfaces. So if you decide you need higher resolution, you can go ahead and bump this up to the next level. Of course, that will require recalculating, and you can see it's just chunking right along there, but boy, it looks good. Here I've reduced my resolution, well, actually increased my resolution by reducing the number from 10 millimeters to 1 millimeter, and also increased my subdivision surfaces from 8 to, I believe it was 12. And it's obvious, you may not be able to see it in the playback on the CD, but it is a much finer resolution to the cloth. Now we just have it waving back and forth here, but it's very natural, very smooth. And in the next step, we're going to be adding some collision objects to this, and that's where that resolution setting will really come into play, because when the cloth is draping over an object that's a collision object, once in a while you have a corner peeking out, and that's because the resolution wasn't high enough or the geometry count wasn't high enough. And one more setting I'd like to address here is I've reduced the resolution and the subdivision level to a more practical level, so it can run a little faster here. We have something called interpenetration of our polygons here. See, it's particularly nasty right here. I've given it a little bit of twist just so I can have this happen on purpose. This is not a good thing. It's not very natural. We don't like it. And remember, even though these are two separate pieces of geometry, or they at least appear separate, they really are one object. So what we need to do is adjust our collision settings so we don't get that interpenetration. And that setting is under collision. Go figure. So the setting we really want right now is ghosted. It says self-collision. That's because we have to turn on our collision functions. And right now, this does not really become a collision object in that it is hitting something, but you're telling it that it will react to a collision object or an object that has the collision setting applied to it. So right now it's kind of the victim object. So we need to turn on collision, and if we calculate this, nothing's going to change because it's still intercalating. We can even see it in the preview here, as we need to have it self-collide, much like in the hard-body dynamics, where we had to tell the letters that they would collide with themselves. And interesting, we can set it up with the point sets, with the surfaces, or with the weight maps. But I'm just going to select all, which means it will detect self-collision with all of it. So we'll hit calculate. And it may take a little bit longer because it has much more math to do when it's hitting each other. And let's see if that made any difference. As we scrub through our animation here, we can see the places where they would have collided, say right there, and they are not. And also right there. Give us another view of what's going on here. A few of the settings to be aware of when you're working with collision and self-interaction. Set the interaction for all, collision detect for all. And that's just, in this case, that makes sense that you would want the whole thing to react. The collision offset. Oh, yes, and the self-collision needs to be set to all. At least in this case it does. If you only want parts of it to pay attention to self-collision, at this point I can't think of any reason why you would not want all for self-collision, but there are a lot of interesting projects out there, and you never know why you might want something to do something in a certain way. So this is the very important setting right here, collision offset. Now what collision offset is, and you'll find this when you're working with other collisions as well, and we'll bring it up again, but it's important to note now. This is set at 50 millimeters. This object is about 2 meters across. So that's a half a centimeter. But what the collision offset is, when something collides, because we're not dealing with real objects, we're dealing with approximations, and sometimes you get smoothing errors, the offset basically expands the collision radius a bit. And here it's expanding it to 50 millimeters. Now I tried the original setting, which was 10 millimeters, and I did get some interpenetration. In fact, if we knock this down, let's put it down to 1 millimeter, and I'm going to run a calculation on this. And I got a feeling we're going to see a little bit more interpenetration of our curtain here, because 1 millimeter is just a little bit too tight. Yeah, you can see it. Something's happening right down in there. Although it's not too bad. There was another one. Some more interpenetration. It's just a rounding off error, basically. Now this is odd because the smaller the number it is, the tighter it gets to the collision radius. So you're actually better off making it a little bit higher. But then you get the problem that it will kind of be riding up. It'll be floating above where you want it to collide. And, you know, a lot of that just depends on the camera angle. And we can see that at 20 millimeters looks like right about a right setting for that. So now that I've got that setting, I'd probably go back into my, crank up my resolution by turning it down, and also go into my geometry and giving me more geometry to work with. I am very close to the ballpark. Chances are when I set a higher resolution, I might still need to do a tweak or two on, say, one of the other settings, the collision settings, to set the interpenetration or the resolution, but I'm going to be pretty close.